Hello, today we talk about Kirchhoff's theory. This Kirchhoff, in English we call Kirchhoffs, but actually it's German, so it's a Kirchhoff. And one of those classroom, I read this Kirchhoff's, the German style reading, then student laughed and said, no, that should be Kirchhoff. Fine. I mean, Kirchhoff is used only in the United States, and everywhere else people read this. If you go to international science conventions, everybody read this Kirchhoff. No, Kirchhoff, not the Kirchhoff. Okay. This theory is it's said a law, but it's not law. It's a theory. This theory or method of analyzing circuit is the basic of all the electrical engineering circuit network analysis. Okay, so what's happened is you have basic element R, and there's a Ohm's law V and I. Ohm's law say Ri equals V. So when you have a complicated network, R1, R2, R3, R4, it's all interconnected like that. So how do you analyze it? It's going to be simultaneous linear equation. So this is called linear. Okay, and what you do is you have a two-way to use the Kirchhoff's law. Okay, in the network there are two ways to analyze. One is a node, and another one is a loop. And the node, you look at the network, you pay attention to every node. The node 1, node 2, node 3, node 4, and you formulate equation. The say node 1 is you have a ground. From ground, the voltage is E1 and E2. Then the difference is this voltage, and P1 is conductance, the 1 over R1. Okay, you multiply that and you do the same thing. So the node, you go around, then the voltage become balance 0. Okay, so you make a full equation for this, and it's solve this linear equation. You solve it for E1, E2, E3, E4. So you get the voltage of node 1, node 2, node 3, node 4. So once you know those voltage, so you know everything about this circuit. For example, what is the voltage from here to here? It just subtract the voltage, you know it. What is the current? This voltage times this P3 is going to give you the current. Okay. On the other hand, the loop, you find every loop. Okay, now before you find the loop, you have to know how many unknown parameters here. The objective of loop method is to find the current. Okay, so the current, loop 1 is I1 R1 plus R2 R2 plus I3 R this current and this current give a voltage, and if you come back to the same point, then voltage is same, so there's no voltage. Then when you have a voltage, you have a voltage supply, then it's come out to be voltage, right? Now, can we make any loop? The important thing is every parameter are interdependent. So you cannot choose a loop. They are separated. They have to be somehow has a common branch together, like this loop and this loop has a common branch, this guy and this guy, right? So everything's interdependent. Make sure you have the every component covered, and every loops are connected with other loops. Okay, so same way you make a linear equation and solve for the I. So if you know the I here and I2, after this you solve this equation, then you know everything about the circuit. So there are two ways to solve the circuit. Okay, now in the previous video, I talked about impedance. So using impedance, R is replaced with generic R plus J omega L plus maybe J omega C. It's become a complex number. The complex number is still this Z. You have Ohm's law. So as long as you have this Ohm's law using complex number, so you can analyze AC circuit, right? And say like a filter, you have a distributed capacitor, inductor, capacitor, inductor, capacitor, inductor, and load R. Okay, and C, this is distributed, and L, 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 this kind of circuit you can solve using Kirchhoff's method, right? Either node method, node 1, 2, 3, 4, 5, or loop 1. Loop, you have to know the current of this. So 2, 3, 4, 5. How many current you have to know? The 1, each branch, 2, 3, 4, 5, 6, 7. Okay, so 7. So you need 7 loops. So in this case, maybe node method is quicker because you have only 1, 2, 3, 4 nodes. Okay, so you set up unknown parameter, unknown value E1, E2, E3, E4, and this is the AC voltage because this is V AC. So using impedance, this impedance here is J omega L, and this impedance here is 1 over J omega C. So using impedance, you do the same Kirchhoff's method to solve the AC circuit analysis. Okay, so DC or AC, as long as it's linear, Kirchhoff's theory works. Now we have extended that theory into more complex case, non-linear. For example, bipolar transistor has characteristic is like that. This is IC and this is IB, 1, 2, 3. Okay, and this is the VCE, and that's not linear. So how do you handle this? Well, you have a nonlinear component. In this case, has a 3-terminal. Okay. If small signal, we can linearize it, which is we make it model IB and R and current source E. So what's happened is this is going to be GMIB. Current source is linear component. So the small signal, we can linearize transistor and use Kirchhoff's theory, same way. But if not small signal, the computer program called SPICE is going to calculate this IB and E, this voltage, using this non-linear curve, and this one is done by iteration to get the approximate value. So if load is here, this value or this value depend on this voltage, it's calculated using iteration. Means when you need to find this curve crossing this X and Y, you learn this in the math. You start from here and you calculate cross point, and cross point you iterate this to get exact value. Okay, so every nonlinear component can be interconnected. Okay, and using this, including nonlinear and of course some linear component, use basically same method, Kirchhoff's theory, and that's a linear simultaneous linear equation, and computer program calculated, and this is most general purpose software that solved Kirchhoff's theory using interconnection of nonlinear element. Okay, so then you can even calculate a transient characteristic of the circuit, like when you apply voltage, then it goes up and come down and goes up again, kind of this is output, input, this kind of curve you can calculate using the SPICE. So once you master the SPICE software program, then pretty much any circuit with bipolar transistor and MOS transistor, you can calculate the operation of the circuit. But it's all based on Kirchhoff's theory. Okay, so this is the basic Kirchhoff theory. The most simple, the simplest the case is the linear element resistor, but the AC you can use impedance. And now, nonlinear component, you can use iteration method to calculate the approximate value of the operation and put them together by nodes or loop. The Kirchhoff's theory, you can calculate the entire circuit diagram. Okay, so Kirchhoff's theory is very basic for electrical engineering, and you practice this Kirchhoff method to calculate the circuit. That gives you idea about how computer software can internally calculating the circuit diagram, including transistors, resistors, anything. Okay, that's it for today. If you think it's good, please click the subscription button.